Hello, how are you? I welcome you today to our tutorial, which will go through physics concepts on the topics that we've learned in class, such as densities for grade 10 and length for Form 1. So please, as you prepare for your tests, add this video to your study list. It will help you to remember all the concepts that we've done in class. I'm Sir Fredrick.Jr. and this is the tutorial video. Okay, so as usual, you need to have mass, and volume when you are solving your density. So now, the job is looking for volume for mass of liquids. But remember what we did in class. We learned how to find the volume of liquids and air. Okay, so just to recall is that for us to find the volume of liquids, we know we can't pour liquid on the electronic balance, so we need to find a container. Okay, we need to find a container just like that. For example, if I'm using my beaker or measuring cylinder, okay, so I'll get an empty measuring cylinder, place it on the electronic balance and measure its mass. So for example, if this gives me 5 grams as the mass, so I'll record this as mass 1, which is 5 grams. Okay, then you get your liquids now, which you are measuring. Okay, step 2, you pour your liquid in the measuring cylinder, whatever you are using. So when you pour now your liquid, you go ahead and measure, place it on your electronic balance, okay, and measure its mass. So let's say it goes to 12 grams. Okay, so liquid plus measuring plus a container that you are using or measuring cylinder, this will be recorded as mass 2. Okay, so in this case, so mass 2 is just 12 grams. So then for us to find the mass of liquid, it will be mass of liquid is equal to mass 2 minus mass 1. Okay, so we'll just go ahead and substitute. So 12 grams minus 5 grams, this just gonna be it's going to be 7 grams. So the mass of this liquid is 7 grams. That's all. Then volume, no issue, you just read, because you are using a container which is graduated. For example, if you are using a beaker, approximately you are going to read the volume. If you are using a cylinder, you read the volume of liquid right there from the cylinder. So in this scenario, which we have, our volume is just given as, let me correct it now, the data. So volume is 6 centimeter approximately given. Okay, then mass of liquid calculated is just 7 grams. Then what is the density of this liquid? So the density of liquid can be calculated by mass 2 minus mass 1 over volume. This is just the same as mass over volume. Okay, so we'll go ahead and use this formula then, and also try this. So we'll go first use this one. Okay, so we solved the density, the mass, which we found that it was 7 grams. Then volume is just 6 centimeter cubic. Okay, so then density is just that divided by 6. This will just give us 1.7 grams per centimeter cubic. Done. Okay, if you want to use this formula as well, okay, you just go ahead and do that direct. Okay, so in this one we'll write the way it is. Okay, so mass 2, which we found, it was 12, minus mass 1, which we found was 5, over volume, which is 6. Okay, so this just give us 7 over 6, which will take back us to 1.17 grams per centimeter cubic. Then this is how we solve. That's how we calculate the density of liquids. Okay, so it's not always water. We can put kerosene there, we can bring petrol, whatever, but the important thing, know the concept. Then this prompts us to go to try the mass of density of air. Density of air. Okay, so the density of air is not different. There's no difference with how we find the mass of liquids. So first of all, we'll find mass of air. Then we'll find the volume of air. Okay, so there's important note that you should know. You should note that the volume of a container in which you've placed your air is equal to volume of the same air, of the air. Okay, you should note that. It's important to note that. Okay, then how do we find the mass of air? As usual, in this case we'll use the enclosed thing. Let's assume we have a bottle of Vatra. Okay, I know some of you like drinking water from this bland Vatra bottle. Okay, and this Vatra bottle has a capacity of let's say 750 milliliters. Okay, from the onset of our lessons, from the introduction under conversion of units of volume, we learned that 1 milliliter is just the same as 1 centimeter cubic. So definitely 750 milliliters is just same as 750 centimeter cubic. So we get this empty bottle. All right, what do? We measure its mass. But however, under advanced, what you could do is that inside this empty bottle there is air molecules there inside. So what you do, you measure it. So you press it on the electronic balance. Okay, so and let's assume this electronic balance is reading as 4 grams as your mass. So we'll say bottle with air particles inside, is recorded as mass 1. Okay, so this mass 1 is just 4 grams. Okay, then you go ahead and use what we call a suction tube. Okay, a tube that removes air particles. You connect it somewhere at the point here, or you make a certain aperture there, then you suck the air out. Okay, when you suck the air out, you notice that the mass must drop, so that will be mass 2. Okay, if air is sucked out, so that will be mass 2. So mass 2, let's assume it just change to 3.9 grams. All right, so let's go ahead and find the mass of air. So mass of air will be calculated as mass of air, I'll just indicate there, mass of air will be mass 1, that of the empty bottle with air particles, minus the bottle where we've removed air particles, so mass 2. Okay, then this will be just be 4 minus 3.9 grams. Okay, so what does that give us? It will be just mass of air will be 0.1 gram. Okay, that's how we find. Now I want to give you another tactic. How would you know that this is mass 2 or mass 1 in terms of air? So no matter how we bring it, always just know that among the two masses, the one which has got a high value is the mass that you should subtract from. Okay, so for example, if we just say for example, we have these two masses. Okay, for example, we'll say mass 1 is 2, I'll say 2 grams. Okay, then mass 2, let's say it becomes 2.1. okay, so how are you going to solve here? You use the large value, you subtract from the large value. Okay, so your mass of air will be 2.1 minus 2. This will just give you 0.1 grams grams, yes, just that. Okay, so that's how you are going to tell if the question is very unclear. You go like that. So always know that the large number, it symbolizes the mass together with that of the container. Therefore, you need to subtract from that value. All right. So now, having looked at this technique, let's see how we can solve this problem. We have a problem presented to us. Okay. So we have this question. In an experiment to determine the density of air particles trapped in the bottle, Sir Fredrick of Charterhouse School collected the data shown below. Okay, so this is the data given to us. Okay, mass of empty bottle is 400 grams. Mass of a water bottle filled with air is equal to 400.2 grams. Mass of a water bottle filled with water is just 1020 grams. Then the density of water was given as 1 gram per centimeter cubic. So now let's look at the questions. Okay, so how are we going to work out this question? All right, what is the mass of definitely here supposed to have mass of air. Let me remove this one. Mass of air. Okay. All right, so what is the mass of air? All right, so let's run through the data. So mass of empty water bottle is just this. Then a water bottle filled with air is just this. Like I told you, you just use a common sense there. A number which is larger than the other one is the one where you need to subtract from. So it will be mass of air is just mass 2 minus mass 1. So mass 2 in this case will be 400.2 minus 400, okay, grams both sides. So what do we get? Okay, so go ahead and do the math there. Okay, so we'll find that the mass of air is just 0.2 grams. Okay, just like that. So you are done with the first one. Okay, then we go to calculate the mass of water. Okay, again the same bottle was used to fill water. Okay, so they're saying the mass of a vatra of water filled with water was that. So same formula. So now in this case we say mass of liquid is equal to mass 2 minus mass 1. So mass 1 is the mass of the empty bottle. So mass 2 is given as 1020. So 1020 grams minus empty bottle is just 400 grams. So what do we get here? Mass of liquid will be equal to let's solve that one. So okay, just give us okay, so the mass of liquid was 620 grams. Okay, so that's how we can solve that one. Then the volume of a container. So what quantities are you going to use for you to come up with the volume of a container? Okay, because what we are having initially here is just masses. We've calculated mass of air, we find mass of liquid. We need now to find the volume of the container. So we'll use liquid. Why? Because liquid, we have two physical quantity given. Okay, we have been given the density of water, which is 1 gram per centimeter cubic. At the same time, we've also calculated the mass of what? Of liquid. So when we solve the mass, or when we solve the volume of liquid, then we'll also solve what? The volume of a container. So data collection. So density of liquid has been given to be 1 gram per centimeter cubic. Then mass we've calculated as 620 grams. Okay, then volume we don't know. Okay, if you want, you can make volume as a subject of the formula in this formula, but if you're okay, you can just substitute them. So 1 gram per centimeter cubic is equal to mass 620. Okay, that. So cross multiplication, v times 1 is just v1. It is just v. Okay, then that times that, it just give us 620 centimeter cubic. So this time around we've solved what? The volume of water, or rather liquid. So now, if this is the volume of liquid that was poured in that container, that vatra bottle, okay, perhaps that vatra bottle can have a capacity of 620. So the volume of that container, of a container is same as the volume of liquid that was poured there. So it will still be 620 centimeter cubic. Okay, then density of air. Okay, so we haven't yet solved the volume of air. Okay, so where are we going to get this volume of air? First, let's correct the data for this question. So we are looking for density, which we don't know. Mass of air we've calculated, it is just 0.2, the one which we solved at first, 0.2 grams. Okay, then volume Okay, remember it was the same bottle which was also filled with air, and they used also the same bottle to fill water. So the same amount of water that was poured into this container is the same amount of same capacity or amount of space that was occupied by the same air particles. So the volume of air is also 620 centimeter cubic. So we'll just bring our formula here, that over that. So this is gonna be 0.2 grams over 620, okay, centimeter cubic. So the density of air gonna be 620. It's just going to be 0.00032, okay, grams per centimeter cubic. Okay, if you want, you can also write this in scientific notation. So the point will move 1, 2, 3, 4. So it will be 3.2 times 10 to the power -4 grams per centimeter cubic. This answer is same as that. Okay, so this is how you handle this type of question. I hope it helps you. Thank you.